Hello Year 9s and welcome back to Mathemagic. As you can tell, this is Mr. Noakes. My name is Mr. Lee and I'll be taking you guys on your journey in mathematics for the rest of this year and hopefully helping you guys along in your studies of mathematics. Now, unfortunately, we find ourselves in a bit of a predicament at the moment with COVID-19 in New South Wales. This is the general structure that I'm going to try and do whilst we're doing online learning. I'm going to be posting up videos every lesson that we have so that you can watch it at home and follow along in your books. And then I'll give you a few questions for you guys to practice the stuff that we go through in these lessons. So that should be the general structure of what we are doing as we are doing some online learning. So this term, we're starting off with a new topic. We're starting off with a topic called linear relationships, which is what I have here in the heading. So today's lesson, we've got the learning intention and success criteria on the screen. Hopefully you can see that in front of you. We are starting off this topic of linear relationships, and it's gotten some stuff that you've looked at before, hopefully in year 8. So what we're going to be able to do by the end of this lesson is to recall plotting points of the Cartesian plane, filling in a table of values and plotting points on the Cartesian plane, finding x and y intercepts, and then rearranging linear relationships. Now, to give you an idea of what this topic of linear relationships involve, I want to actually draw some connections with linear relationships. Actually, draw some connections with another topic you've actually looked at earlier this year. The topic that you looked at earlier this year was algebra. So earlier this year, you looked at algebra with Mr. Noakes. And so, for example, you did things such as you were able to solve equations. You could simplify expressions. You could substitute values. And you could use formulas, for example. Formulae. And so those are all these skills that you looked at earlier this year, and I think it was in term 2. I think you guys looked at some algebra skills in term 2 with Mr. Noakes. That was all the stuff that you did with algebra. But what this next topic of linear relationship does is it builds a bridge between algebra. So here, this is where our linear relationship. It's a bit of a bridge that links up, and then now we have a connection between the two, between algebra and another topic called geometry. What linear relationships is basically helps us to understand this topic of linear relationships, in particular using the Cartesian plane, helps us to build an understanding or visualize how algebra can work in a geometric way. And what this looks like is we're going to be able to plot algebraic things on a Cartesian plane. So hopefully last year we looked at Cartesian planes and you have noticed that we used a few algebraic terms and letters. And we're going to actually be able to use that and build relationships between these two topics. So geometry was looking at the study of shapes, angles, positions, and all those fun things that we look at in geometry. So that's what we're going to be doing in this topic of linear relationship. We're building linear relationship is that bridge that gets us from algebra stuff that we've looked at earlier this year to looking at geometry stuff. And that's what we're going to be looking at in this topic. So the first thing we need to actually do is look at the Cartesian plane again. So hopefully in year 8, you remember looking at something like this. So the Cartesian plane. This is what a Cartesian plane looks like. It has two lines that intersect at 90 degrees. So we've got this line over here and this line over here. And what the Cartesian plane is really useful for is it helps us to actually accurately describe a position on a 2D plane. So if you have a look here, I can accurately describe any position along this grid using the Cartesian plane. And if you remember from last year, these two lines I've highlighted in red and blue have a specific name. This horizontal line is called our x-axis. Our x-axis is our horizontal axis. Horizontal. I can't spell half the time. It tells you where your position is on the horizontal line, where you are going left to right. And the other one, if you remember, was called our y-axis. And this is our vertical axis. This is where we are on the vertical plane, going up and down. And so, when we combine these two, we can tell anyone the position that you are on along this grid in a really accurate way. And so that is the part of our Cartesian planes. And there's also one more point I'd like to add usually. This point in the middle, this point, has a special name. This is called the origin. It's where the two plane axes meet. It's where your x-axis and your y-axis meets down in the middle. So this is called our origin. Now this is really great, and this is a really powerful tool that helps us link algebra with geometry. This tool that we're going to look at, it helps us visualize a lot of algebra stuff that we've been talking about in solving equations and also algebraic expressions earlier this year with Mr. Noakes. But the way we need to do this is we need to be able to actually put points on the Cartesian plane. And so we call these points coordinates. Now, last year, hopefully you may remember that when we plot coordinates on a Cartesian plane, it involves two numbers. Two numbers. And the way we write it is we open up a bracket, put a comma in between, and we close up our brackets. And we've got two numbers in these big gaps I've split up. The first number that we need to have is our x coordinate. This tells us where we are on the horizontal plane. So the first number in your coordinate is your x coordinate. And hopefully you've noticed the pattern. The second number that we're going to involve is our y coordinate. This is where you are vertically going up and down. And so when we combine these two, we can tell anyone the position on the Cartesian plane. So for example, if I had the coordinate 2, 1, all I need to do is go, okay, well, 2 is my x coordinate. And so I'm going to go to where 2 is on my x-axis. So I'm going to go over here, look at my x-axis, and look, 2's over here. And so that is my horizontal position. That's where I am horizontally. The second thing I need to do is just look at my y-coordinate. 1, that's my y-coordinate. So I'm going to go to where 1 is on the y-axis, over here at 1. And all I need to do is just line up those 2 points and go, okay, cool. My x goes up here, my y goes along here. And so this point over here is 2, 1. Let's do another one just to make sure that we're on the right page. So let's do another example. So let's say -3, -2. Once again, same pattern. The first number is your x coordinate. So -3 is my x coordinate. I'm going to look at where -3 is on my Cartesian plane. That's all the way down over here. Ooh, excellent. And -2 is my y coordinate. So instead of going to the positive up, I'm going to go down to -2. And all I need to do is just line up those two, and that will tell me that down here, this point here is -3, -2. So hopefully this is just a quick bit of recap of stuff that you've looked at in year 8. So this is how we plot coordinates on a Cartesian plane. We first start off with our x coordinate, so that tells us where we are horizontally. And then after we've done our x coordinate, we plot our y coordinate, where we are vertically. Okay, so that was just a quick bit of recap on the Cartesian plane. What we're going to actually do using this is we're going to start talking about what linear relationships are. Now, here's a quick definition. A linear relationship is a set, a whole bunch of ordered pairs. Now, ordered pairs is just another way of saying coordinates, because, as you've noticed, our coordinates are made up of pairs of numbers. We've got 2 numbers in all our coordinates, and it matters which order they come in. It matters what order they come in. Our x is always first, and our y is then second. So here, a linear relationship is a set of ordered pairs or coordinates, which when graphed, gives a straight line. So what does this mean? Well, if I could draw, let's say I drew a Cartesian plane over here. So I have my Cartesian plane here. I've got my y-axis and my x-axis. And if I could find a rule, a set of pattern between my x and my y's, where if I went, okay, I'm going to plot a point and it gives me a point here, 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 a point here, gives me a point here. And notice here, all of these points, they end up forming a straight line. Does everyone see that? There should be 45 like that. If there is a rule that makes me, allows me to be able to plot a few points on a Cartesian plane and forms a straight line like this, that is called a linear relationship. So a linear relationship is a rule or pattern which gives us a set of ordered pairs or coordinates, which when graphed gives us a straight line. And there's two ways that linear relationships happen. So two ways. The first way has a special name called the gradient intercept form. Now the gradient intercept form, these are just formal terms that we're using for this, but I'm just going to introduce it to you here. The gradient intercept form looks like this. Y is equal to mx plus b. Now m and b are just random numbers. Here we don't know what they are, we're just using letters to represent what they are. But here I have a relationship between my y and my x. It's telling me y is equal to mx plus b. So for example, I could have an example like this. Y is equal to, instead of writing m, I'm going to say, okay, let's have some random number, 2x plus 3. If I have this rule, if I was to graph this on a Cartesian plane, it would form a straight line. That's what it's telling me. The other form we can have a linear relationship in is called the general form. And how the general form works is it looks like this. Ax plus by plus c is equal to 0. So once again here, just like my m and b before, a, b, and c are just 3 random numbers. So you can pick any 3 random numbers. So for example, I could pick, let's pick 1, 2, and 3. So if I picked 1, 2, and 3, I would have, okay, 1x plus 2y plus 3 is equal to 0. If I have this particular rule, this would give me a straight line. Now, some of you might be thinking at home, hang on, Mr. Lee, there's something wrong with this. And there is. We never write 1x now, do we? So here, this, instead of writing 1x, I could just write that as x. So here, these are the 2 ways that we can get a straight line, a linear relationship. So when I graph either of these two on a Cartesian plane, it will form a straight line. Now you might be wondering, okay, Mr. Lee, you've introduced us to these different forms of linear relationships, but how do I even get to that point where I can put it on a Cartesian plane? That is an excellent question. The way that we do this is by creating a table of values. And so what we want to do is we want to be able to fill in a table of values and plot these on our Cartesian plane. And that's what we're going to do in this next section. So whenever you see a rule, if you get given a rule like y is equal to mx plus b, so y is equal to 2x plus 3, or in general form, x plus 2y plus 3 is equal to 0, what you want to do is create a table of values so that you can plot this on a Cartesian plane. So the way that you plot this on a Cartesian plane, first step is you fill in your table of values. And here are the steps that you're going to follow when you are doing that. Step 1. Draw a table with 2 rows. So what you want to do is create a table that has 2 rows. So row 1 and row 2. And these 2 rows, we're going to label it with x and y. So in my top row, I'm going to have x and y. Okay, and y is at the bottom. There we go. So that's my first step. I'm going to draw up a table where I've got 2 rows, x and then y at the bottom. Then what I'm going to do next is I'm going to fill in the x values based on what you require. So the question will usually tell you, fill in a table of values from -3 to 3, for example, or -2 to 2, or it could even be 0 to 3. What you want to do is just in your x row, just put in those numbers. So if I had to go from -3 to 3, I'm just going to put -3, -2, -1, 0, 1, 2, 3. There we go. That's all you need to do. If it was going from 0 to 2, then in my X row, I'm just going to go 0, 1, 2. I'm just going to fill in a few values. Sometimes it's actually nice to put in fraction values, but here, just to make it easy for us, we're going to put in whole number values. Okay. And the final step that we're going to do is then substitute these X values into the linear relationships to find the Y values. What we're going to do is we're going to substitute each one of the X values. So I'm going to substitute, for example, 0. Then I'm going to substitute 1. Then I'm going to substitute 2 into the rule that they've given me. And that will give me in separate Y values in these different points. So here I'd get, for example, 5, 6, 7. And that would be me filling in my table of values. And using this table of values, we can actually plot on a Cartesian plane that linear relationship. So let's have a go at that. So example number 1, filling in the table of values and graphing. So using the values of -3 to x, -3, x to -3, or to +3. So here this just means I'm going to take -3 to x to -3, well, to +3. So x is going to be between -3 and 3. I'm going to construct a table of values for the following rules and then plot them on a Cartesian plane. So I want to construct a table of values and then plot the graph on the for the linear relationships. So let's have a go at this. The first one, this is a rule that we have. Y is equal to x plus 2. So I'm going to have that in front of me. I'm going to notice that. And I want to create my table of values. So here I'm going to go, okay, my table of values is I'm creating my x and my y. I'm going from -3, -2, -1, 0, 1, 2, 3. There we go. So that's my x values done. So I've put in my table of values. I have my two rows, x and y. And then I've put in my values that I want to substitute values for. So I'm going from -3 all the way up to 3. Okay, so I've done that. And what I'm going to do now is I'm going to substitute each one of these values into my rule. So if you remember from algebra earlier this year, when we substitute, we are replacing the letter. So here in this case, that would be x with the number that I'm given. So here I'm going to replace x with each one of these numbers individually. So I'm going to start off with -3. So here, this is my rule. Y is equal to x plus 2. So I'm going to have here, for this particular box, I'm going to write y is equal to, I'm replacing x with -3 plus 2. And when I do -3 plus 2, we can check that with the calculator if we want, but this will give me -1. And so here I'm going to have -1. Okay, I'm going to repeat this process for each one of these boxes. So then I'm going to move on to the next one. I'm going to substitute -2. So for this box, I'm going to have y is equal, let me keep consistent. Y is equal to, instead of -3, it's going to be -2 this time. -2 plus 2, because that's what the rule tells me at the top. Okay, so -2 plus 2, that will give me 0. And so here, this gives me 0. Okay, third box. What am I going to replace x with this time? Hopefully you answered it along at home. I'm going to replace x with -1. And so here, for this box, it's going to be y is equal to -1 plus 2. And so here, this just becomes 1. Now, after you've done a few, hopefully you'll start to notice a pattern. We can keep going with this. We can keep substituting all the values in and just to make sure that we've got the right thing. But after a few, you'll start to notice a pattern. What do you notice is happening each time I go along in my table of values? Well, each time I'm going along, I'm just adding 1 each time, aren't I? And so once you start to notice a pattern, you can actually just quickly fill in the rest by applying that pattern. So let me just do the next one just to check. But if I was following that pattern, the next one should give me 2. And so let's just substitute the next value in. Here, for this box, I would get y is equal to, I'm going to replace x with 0 for this one. So here I'm going to get 0 plus 2. And so here this just becomes 2. Exactly what I asked for, was expecting. So here for the rest of them, I'm just going to keep adding 1. So the next one should be 3, 4, and 5. And so that's how we fill in the table of values. What you want to do is you want to substitute the value in, so the x value at the top row, and then that will help me get the value in the bottom row. Okay, now what we need to do in the second part is actually plot this on a Cartesian plane. The way that we plot this on a Cartesian plane is that we look at each one of these columns. So here, I'm just going to erase all this working out, and I'll get back to here in a moment. What we want to do is when we are plotting this on a Cartesian plane, we're going to look at each one of these columns. I'm going to look at this first one. What this first one tells me is that on my Cartesian plane, I'm going to have a point where x is equal to -3 and y is equal to -1. And so if I was to draw this on my Cartesian plane, I'm just going to go, okay. This is y, this is x. Let's go, ooh, just realized my thing is not going to go to scale. I'm just going to go up by 2 each time. 6, 2, 4, 6. I'm going to go 2, 4, 6. Oh, hang on, this should be -2. -2, -4, -6. Here we've got -2, -4, and -6. Now here, if you have a look at that first one, I've got -3, -1. So this corresponds to a coordinate of -3, -1. And so I can put that on my Cartesian plane now. I can go, okay, -3 is over here somewhere. So -3 would be over here, and -1 would be over here. And so that would mean I have a point over here. Okay. I'm just going to repeat this process for the rest of my table of values. So the next one, I would have this point over here. So -2, 0. So here, this would just correspond to the coordinate of -2, 0. So I'm going to go on my Cartesian plane again. I'm going to go to -2 on the x-axis. So here, x-axis, I have -2, which is over here, and y coordinate of 0, which is just means it's on the x-axis there. Excellent. I'm just going to keep repeating this process. Next one, -1, 1. And so that would be over here somewhere. So -1, 1. 0, 2, which is over here. The next one is 1, 3, which is over here. 1. And then 2, 4. And then 3, 5. And so what you notice here is if you have a look at all those dots I've drawn, they form a straight line, which is exactly what I should expect. So I can draw a straight line through them like this. And there we go. There we go. We've plotted this particular rule. Y is equal to x plus 2. There we go. Cool. We've done one example. Let's have a go at another one. Next one over here. This one's a little bit trickier. Y is equal to -2x plus 2. Let's have a look at this one. So y is equal to -2x plus 2. Once again, we're going to create our table of values. We're going to start from -3. I'm going to go all the way up to 3. And so what we want to do, we've drawn our table of values. We're just going to substitute each one of these values in. So let's do that. First one, I'm going to substitute -3 into this rule. So here, I'm going to, for this first box, I'm going to have y is equal to -2. Now, when you see -2x, there's a hidden operation there. The hidden operation is -2 times x. And so what I need to do here is I need to do -2. That's part of the rule still. -2 times -3 plus 2. Okay, so we need to do this operation when we need to substitute our values in here. So here I've got -2 times -3. Negative times negative makes a positive. And so here we just get 6 plus 2, which gives me 8. So this first one is going to be 8. Okay. Next one, let's have a look at this next one. So here I'm going to get y is equal to negative 2 times, what am I multiplying it by this time? It's going to be minus 2 because that's the value at the top of my column here. So this is going to be minus 2. And in my rule, it's still plus 2 at the back here. Okay, so I'm going to do this again. Negative times negative gives me a positive. So this becomes 2 times 2, which is 4, plus 2, which gives me 6. So next one's going to be 6. Let's do one more, and then hopefully we'll start to see a pattern. Next one is negative 1. Now here we're going to do this one again. So this is going to be y is equal to, according to my rule, I've got negative 2x plus 2. So it's going to be negative 2 times, this time, negative 1 plus 2. So here, this just becomes 2 plus 2, which is 4. So this one's going to be 4. Now after doing a few, hopefully you're starting to notice a pattern. What do you notice each time we're going across by 1? Well, every time we're going across by 1, we seem to be going down by 2. So minusing 2 each time. So the next one, we should expect to get 2. Let's just do one more substitution. So I'm going to do this one all the way down at the bottom here. So y is equal to negative 2 times 0 plus 2. And so here, negative 2 times 0 gives me 0. And so this answer will just give me 2, which is exactly what I got. I was expecting. So there, excellent. So we're just going to go down by 2. So we're going to go down by 2 again. So this should give me 0, then negative 2, then negative 4. Once I've done that, I've filled in my table of values. Excellent. I can, from here, now I can actually plot this on a Cartesian plane. I'm going to plot this onto my Cartesian plane. So I'm going to draw up a Cartesian plane. Now what you want to do is you want to be able to fit in all these values. So I want to fit in from 8 down to negative 4. So I'm actually going to draw this a little bit wider this time. So I can hopefully fit this in. Oh, I actually want this to be a little bit taller, my bad. So I want to go from 1, 2, 3, 4. I'm actually going to go up by 8 each time. Oh, there goes my lighting. There we go. I'm going to go up by 2 each time. So I'm going to go once again 2, 4, 6, 8. Down here is negative 2, negative 4, negative 6, negative 8. I'm going negative 3, negative 2, negative 1, 1, 2, 3, and that's my x and my y axis. So here notice I've actually used a different scale on my x-axis and my y-axis. So on my y-axis I'm going up by 2 and my x-axis I'm going across by 1 each time. As long as both of them are equal, as in you're doing it evenly across each one, it should be okay. So let's plot these points on. So the first point that I have, this one over here, that is a coordinate of negative 3, 8. And so here I'm going to go to where negative 3 is. Negative 3 is over here. 8's up here, and so I'm going to line the 2 up, and so I get a point over here. There we go. Next one, this coordinate is negative 2, 6. And so here I'm going to go to negative 2, I'm going to go to 6, line them up, got a point there. Next one is negative 1, 4. So negative 1, 4 is over here. Excellent. Next point is 0, 2. 0 is over here on the x coordinate, and then 2 is over there, x axis. And then next one is 1, 0, which is down here, 2, negative 2, and 3, negative 4. And so what happens here is, if you notice, we got another straight line. Yay! It's exactly what we want. And there we go. We've drawn our second example. So this is my y is equal to negative 2x plus 2 graph on a Cartesian plane. Excellent. Okay, cool. The final thing we need, so that is actually plotting our point, or plotting our rule on a Cartesian plane. So what we want to do is we want to fill in a table of values. So draw your table of values, x and y, and then put in your x values that you want to fill in your Cartesian, on your table of values, and then substituting values in. Only once you start to notice a pattern can you actually keep following that pattern through. I want you actually to get some practice substituting those values in. Okay, so we've we've filled in a table of values. Well, actually, we've plotted points on a Cartesian plane. We've filled in a table of values and we've plotted them on a Cartesian plane so that we've created a straight line. What we want to actually look at is the next thing that we're going to look at is this concept called the intercept. So here, we've got a quick definition. An intercept is the point at which the line meets an axis. So what this actually looks like. So if you have a look, this is an example of a linear relationship that I've drawn. So here I haven't got the dots showing each of the points, but we can imagine that there's dots in between if I filled this in at different points. An intercept is where the points at which the line, this red line here, touches my two axes. And so here I've actually indicated them. My two intercepts are 3 and 2. That's what an intercept is. It's just where this line touches the two axes. And on a 2D Cartesian plane, there are two intercepts. So notice here, I've got two intercepts. Two of them. And they're really simply named based on where they touch. The first one is called our x-intercept. This is where our line meets the x-axis. So if you have a look at the diagram I have underneath here, which one of these is my x-intercept? Well, it's just going to be this one over here at 2. So here my x-intercept is 2. Okay, pretty straightforward. And the other one, hopefully, if you're following the same patterns that we've noticed here, we've dealt with x's, so the other one has to be our y-intercept. And so here, the other intercept that we have, the other point where the line touches the axis is on my y-axis over here. So this guy here is my y-intercept. No, my y-int. I'll shorthanded it. 3. So there we go. That is what an intercept is. What we want to be able to do is actually identify what the intercepts are. And so the way we do this is when we are finding x-intercepts. So here, when I find an x-intercept, what I want to do is I want to actually find the point where y is equal to 0. Y is equal to 0. Now, you might be thinking, well, why is that? And actually, let me fill this in before I tell you why is that. And we want to find the y-intercept. We want to find where x is equal to 0. Now you might be confused. It's like, well, so these are like swapped around. Why isn't just when the x-intercept is where x is equal to 0 and the y-intercept is where y is equal to 0? It's a good question. If you have a look here, well, let's have a look at the x-intercept, those two particular points. Let's first start off with our x-intercept. If I had this coordinate here, what would that coordinate be? Well, this coordinate here would actually be written out fully as 2, 0. We have an x value of 2, x coordinate of 2, and a y coordinate of 0. So when we want to find an x-intercept, we actually want to have the y coordinate being 0. Similarly, let's do the other one. This one over here, this point, well, just remember your x value comes first and then your y value comes second. So this one has an x value of 0 and a y value of 3. And so when we're finding an y-intercept, we actually want to have our x-coordinate being 0. So here, the reason why these two are swapped around when we're trying to find these intercepts is because we want the other one to be 0 in order for us to find that particular intercept. So this is our y-coordinate. So when we're finding an x and y-intercept, we want to have the other coordinate being equal to 0. So here, that's what we're going to have a look at in these examples. So write down the x-intercept and the y-intercept from this table in the graph. Now, the graph we did in the first example, and it should be quite simple. Actually, let's do that one first. Let's have a look at this graph. What is the x-intercept? Well, the x-intercept is just where the graph touches the x-axis. So I'm going to have a look on this graph. X-axis is over here, and so it touches at -4. So I'm going to just write here, x-intercept is at -4. Pretty straightforward. And so my y-intercept is just where it touches the y-axis, which is up here at 6. So the y-intercept is just going to be 6. Pretty straightforward. Now here, when we have a table of values, this is a little bit trickier. What I said earlier here was, when we want to find the x-intercept, we want to find when y is equal to 0. So let's deal with the x-intercept first. This particular rule, x-intercept. I want to find where y is equal to 0. So what I'm going to do is I'm going to look at my y values down here. I'm going to look at where is y equal to 0. And hopefully you've all noticed that y is equal to 0 is that last value here. And so all I need to do is just read off the other value. So here, the x-intercept is just going to be equal to 3 because that is where y is equal to 0. So I'm going to put this in pink just so we have it color coordinated. Okay, now the other thing that I said was when we want to find the y-intercept, we want to find where x is equal to 0. So here I'm going to go, okay, I'm going to look at my x values. I'm going to find where x is equal to 0. And hopefully you've noticed that x is equal to 0 is over here at 0. And so all I need to do is look at the other values. So y-intercept, my y-intercept is just going to be equal to 3. And so that's how we find x and y intercepts. Okay, so there we go. Have I got anything else? Ooh, we'll actually leave that for another lesson. So that's how we go about these particular questions. I'm going to leave you guys a few questions so that you can have a go at, so you can practice, in particular, substituting values into a rule and then filling in the table of values and plotting that onto a Cartesian plane. Hopefully you'll be able to submit it so that I can have a check of your work and give you some feedback. But other than that, year 9s, stay wonderful. Hopefully you guys are staying safe during this this lockdown, and also hopefully we'll be able to see each other again in person shortly. But yeah, I'll see you next lesson, year 9s.